Here we're going to have a look at a simple turbojet engine to get a better idea of just what goes on inside a turbojet engine. So this engine here is an Armstrong-Siddeley Adder pure turbojet engine. It was originally designed in the late 1940s and first found application in the Jindevik aircraft, which is a small pilotless aircraft that was remotely controlled and was used as a target aircraft in the early 1950s. That aircraft was designed by the government aircraft factories in Australia. So we're looking at this engine because it's a simple engine to look at. So it's a pure turbojet engine. Also, this engine has been sectioned, so parts have been cut away so that we can see what's actually going on inside. And the other thing that we have is there's a small electric motor down this end of the engine which is hooked up via a belt to the shaft that has the turbine and the compressor on it. We're able to rotate that shaft so that we can see what happens inside the engine. So this section of the engine is the intake. This section of the engine here is the compressor. This section of the engine is the combustion chamber. This section of the engine is the turbine. And this section of the engine is the exhaust nozzle or the thrust nozzle. The intake draws air into the engine so that it's ready to be compressed by the compressor. In an engine installation on an aircraft, there'd normally be a nacelle around the whole engine, and there'd be a bit of a diffuser at the start of the engine. That would take in the air and slow it down a little bit, raising its pressure and temperature before it entered the compressor. The air from the intake then enters the compressor. So this is the compressor here. You'll see that it's a multi-stage compressor. So it consists of a series of, in this case, 10 stages of compression. This compressor raises the pressure by a factor of 5 as it passes through the compressor. The compressor consists of some blades which rotate and some blades which are stationary. So we call those the rotors and the stators. Each stage of compression is raising the pressure and temperature a little bit. So when we multiply that together, we can get quite a large pressure rise across the compressor. This is an axial flow compressor, which means that the flow is primarily travelling in the direction of the axis of the engine. And with an axial flow compressor, we can get quite a large pressure rise for a large mass flow rate of air passing through the engine. The gas which has come from the compressor then enters the combustors. This engine has 6 combustion chambers around the centre of the engine. The air that's come from the compressor goes through the combustion chambers. Some goes around it. The fuel is coming in through this line here. The combustion chamber that would have been here would have fuel injected at this point here. In the next combustion chamber, we see the fuel being injected around this area here. The fuel then burns with the air and we release the heat that's in the air, and that air, the hot air, then goes through the end of the combustor and is ready to go into the turbine. The flow from the combustion chamber enters the turbine. This is a 2-stage turbine consisting of a stator and a rotor, a stator and a rotor. The stator puts swirl into the flow, which drives the turbine round so that we can extract the power from the flow. At the end of the stage, the swirl is removed by that stage of the turbine and the flow is approximately axial again, and then we're ready for the next stage. The rotating parts of the turbine are connected via a shaft running up through the engine to the rotating parts of the compressor. So the turbine and the compressor both rotate at the same speed. The turbine extracts the power that drives the compressor. Since there's nothing else to drive the compressor, any power the turbine extracts is that which drives the compressor. The flow exiting the turbine is still more energetic than the flow that entered the engine. So we want to take that flow and direct it out through the last section of the engine, the nozzle. So if we can get the gas coming out of the nozzle with a higher momentum than we had air entering the engine, then we can produce thrust out of the engine. So if we were to inject some fuel into this engine, and get that fuel to burn, it'd be driving our turbine, which would be driving our compressor, and we'd be producing a lot of thrust.